Hello E11s, welcome to Domestic Electricity or Mains Electricity. So in today's lesson we are going to see the frequency and voltage of the AC mains supply, the difference between AC and DC current, which are the different wires that you find in domestic wiring, and what are the dangers associated with mains electricity or domestic electricity. Okay, so that is what we are going to see in today's lesson. Now, what I want you to do is, you have used so many electrical appliances in your life so far. So let's just narrow that band there. Make a list of all the electrical appliances you have used so far. So pause the video and make a list of all the electrical appliances you have used so far. Okay? Come on, don't be lazy. Pause the video and do it. Okay, so now you have a big list in front of you. Many of you would have written toaster, kettle, hair straightener, hair dryer, all those things, isn't it? Then what would it be like to live somewhere with no electricity supply? Think, if there is no electricity supply, how can you charge your mobile phones? Goodness me, that is your oxygen, isn't it? How can you survive without that? Maybe we can find out a solution for that also. Anyway, so we are going to see by the end of today's lesson, we will actually appreciate how much effort goes into all the electricity that we are getting at home. Okay, so before going to the main concept, we have to recap some key concepts that we have done previously. Previously means we did this in P3, current electricity, which was, I do agree, once upon a time, isn't it? So define the term current. Anybody remembers the definition for current? If you remember or would like to recap before you see what I say, before you hear what I say, a very good idea would be to pause the video, think about the definition in your mind, and then come back to the video and see what it is. So it is a rate of flow of charges or rate of flow of electrons. Rate of flow of charges is the best answer. Then define the term potential difference. How did we define potential difference that time? It is a work done. Potential difference is how much work the electrons or the charges have to do in order to move through a resistance. So it is the work done per unit charge. So the two equations that you have there is I is equal to charge, which is Q over time, and potential difference V is equal to W over Q. Okay, so these are the things that you need to keep in mind. We will need it later on. So the current we talked about, both the current and the potential difference we talked about in the previous slide, they are of two types. One is called the direct current and the other is called the alternating current. So in this slide, we are going to concentrate on the direct current. So direct current is more commonly known as DC. The reason why we call this as direct current is because it flows only in one direction. Okay, so electric current can flow either as a DC direct current or as an AC alternating current. In that, the direct current flows only in one direction. An example for a source of a direct current, the most popular example for the source of direct current is the cells and the batteries that we use in the lab, we use at home. All those are direct current. And the potential difference that comes from it is also direct. It's known as direct potential difference. We don't use that term that often. More often we use the term direct current. So how does it look like? So what you see here on the side is called the grid that you see is a grid that you would see on a CRO. CRO or a cathode ray oscilloscope is an equipment, is an apparatus we use to measure the voltage, the frequency, etc. of ACs and DCs. So it will look like a straight, so you can see that it looks like a straight line, which means its value doesn't change. So say this is 2.5 volt, it will always stay 2.5 volts. And you can see it is positive 2.5 volt, it will stay positive 2.5 volt itself, it won't change. So that is the speciality of direct current or DC. Okay, so it will flow only in one direction. Examples are the cells and batteries. So you know that cells and batteries have a positive and a negative. So current, generally we consider conventional current to be flowing from the positive to the negative. Okay, so all clear about direct current? Then we can move on to AC or alternating current. So moving on to alternating current. So alternating current will change direction regularly. We have seen this actually when we did generators in P4. We did this. We have gone through this. So the power stations where they use generators, they are producing an alternating current. The voltage or the potential difference associated with it will be alternating potential difference. So how does it look on a CRO, on a cathode ray oscilloscope? So you can see that initially it is negative, then it has become positive, it is becoming negative, positive. So it keeps changing direction again and again. Okay, and the example is power stations, the generators in the power stations. So now it's time for a quick check. So you can see two questions on the PowerPoint. Pause the video and write down the answers for them and then come back and check the video. Okay, so question 1, difference between direct current and an alternating current. Question 2, give an example of each. Okay, ready? So pause the video, write the answer and come back. So pause. Okay, so now the answers are direct current, always in the same direction, whereas alternating current, the direction keeps changing. Example for direct current or direct potential difference, it doesn't matter, batteries and cells. And for alternating, our example is a power station. Also, draw how the trace will look like if it is a DC and how the trace will look like if it is an AC. So again, pause the video, draw, and then come back and check. So how will the trace look like if it is DC? It will be a straight line, which tells us that the direction also doesn't change, the value also doesn't change. If it is an AC, it is a curve, it's a sine or a cosine curve, we can say. The direction and the value keeps changing. So now we are moving on to the main part of our topic, which is our mains electricity. So when we did national grid, we already studied that current electricity or the mains electricity is produced in the power stations. From there, using the transformers, pylons and cables, we transport it to different places. So it comes from the power stations to the main homes and mainly to the homes and businesses. Now for this mains electricity, there is two main characteristics of them. One is their voltage and the other is their frequency. So the mains voltage or the mains current keeps changing direction. So that tells us that the mains electricity is a AC. It's not a DC, it is a AC. It changes direction and it has a frequency of 50 Hertz. So what does this frequency of 50 Hertz have to do with the change in direction? Is that frequency of 50 Hertz means that the current or the potential difference changes direction 50 times in a second. Yes, you heard me correct. It changes direction 50 times in every second. Okay, and the voltage of a mains supply is 230 volts. So this one of what is the frequency and what is the potential difference, these two they're very, very, very popular questions that almost pops up every year. Okay. So let's do a very quick check. What is the frequency of the mains electricity supply in UK? 50 Hertz. And what is the potential difference of the main supply? 230 volts. Now I'm going to show you a few devices. You need to figure out which of the following devices have a 230 volts potential difference. Now, your mobile phone. How does it work? For it to work, do you have to connect it to a main socket in your house? You don't have to, isn't it? The battery is connected to it only for the purpose of charging. So that doesn't have 230. Think about the toaster. Yes, it is connected to the main supply, so it will have 230 volts. Remote, it works on a battery, so it doesn't have 230 volts. Kettle, yes, we can see the coil, the wire there. So it is definitely connected to the main supply. So it has 230 OTBS. Anybody has a TV that works on a battery? No, right? So that one also has 230 volt. Now, all of you are familiar with the plugs. So we are going to try and figure out what different parts of a plug is made out of. So you have a cable inside the plug and there is an insulation around the cable. Which one do you think from the four in the orange color would be what the insulation is made of? Think about the purpose of the insulation. So the purpose of the insulation is to protect from a short circuit or an electric current. So it should be something that is not a conductor, or it should be something that is an insulator. So among the different ones we have here, the insulators are rubber and plastic. In that case, it can't be stiff plastic because it has to bend. You have to bend the wires. Case. Case again is something that you touch. So you don't want to get electrocuted when you touch the case, do you? So again, the case should be made of something that is not a conducting material. So that is stiff plastic. And it can't be rubber. It goes wobbly, the plugs then. Then the pins of the plug. The pins of the plug are made from brass because they have to be very strong. And the wire has to be a very good conductor of electricity, and hence it is made of copper. From the different parts of the plug, we are moving to the electrical cable. What do we find inside an electrical cable? So you can see in the diagram there, you have three different wires inside the electrical cable. So then, as we said before, what are those wires made of? They are made of copper because it is a very good conductor of electricity, and so that we can't use a thick copper wire, then it's difficult to bend them. So instead of that, it is made of thin strands of copper wire so that the cable is flexible. The whole thing is put in a plastic casing so that the wires don't touch each other. If they touch each other, they will short circuit. It can result in overheating, cause fire. Okay, so the main purpose of insulating plastic is to prevent any short circuit that is happening. So we have generally seen that the plugs, they have 3 pins. Now why do they have 3 pins? Because the cable to which they are connected has 3 wires inside, like you can see in the diagram. Okay, so the 3 pins are connected to the 3 cables inside. In this, the 2 of those 3 wires inside, I think earlier I said it's connected to the 3 cables. No, it is connected through to the 3 wires inside the cable. In that, 2 of them makes and breaks the circuit, and the third one is a safety feature. So in the next few slides, we are going to see all those details. So if you open the casing of a plug, this is how the inside bit is going to look like. Okay, so you can see there are 3 colored wires there, a blue wire, a green with yellow stripes, and a brown wire. what the brown wire goes to, this one, a small tube-like thing you can see next to the brown wire, this one. That is a fuse. This brown wire is our live wire. So you need to know the colors. Huh? So live wire is brown in color. Neutral wire is blue in color. And earth wire is the greenish yellow one. So our three wires are live, neutral and earth. So live is brown in color, neutral is blue in color, and earth wire usually is green with yellow stripes. Okay, so they can ask you to label it. So this is how you will label it. Now, one problem with this is sometimes, say in the exam, it is highly unlikely that you will get a color picture. So when you don't get a color picture, when you're getting a black and white picture, how are you going to figure out which one is which? Earth wire is again easy because that is the only one that will have stripes on it. Then our thing is to identify neutral and live wire. Live wire will be always connected to the fuse. So whichever wire, irrespective of its color, because in black and white you're not going to see any color, whichever wire is connected to the fuse like this, that is the live wire. The one that is not connected to the fuse and doesn't have any stripes is our neutral wire. Now, what do these three wires do? What are their functions? So a live wire carries current that alternates between a negative and positive value. The voltage of a live wire is 230 volts. So basically, live wire carries current to the appliance. Okay, so carries current to the appliance. Then what we have next is the earth wire. Earth wire is basically just a safety. I shouldn't be saying just a. It looks like I am undermining its role. So earth wire is a safety wire. It makes the appliance safer to use. How? We will see that in another slide in more detail. A neutral wire completes the circuit. So what a neutral wire does is it takes current away from the circuit or away from the appliance. So a live wire takes current into the appliance. A neutral wire takes current away from the appliance. The voltage of the neutral wire is almost zero. Voltage of the live wire is 230 volts. You need to know all these voltage values. And the earth wire is a safety precaution we are taking so that we can still touch the wire even when, touch the appliance even when it develops a fault. So based on the mains electricity topic we did so far, let's answer some questions. The questions are very straightforward, simple questions. So once you see the questions on the screen, pause the video and then do the work out the answers and then come back. Sorry. So these are the questions. So now pause the video and do the questions and then come back. Okay, so where does the mains electricity come from? We have seen that in one of the slides. It comes from the power stations. State which two wires connect a house to a power station. So current has to enter the house, current has to leave the house. And entering and leaving takes place through the live and neutral wires. And that is exactly what the function of the live wire is. It carries current to the appliance. Function of the neutral wire, it carries current away from the appliance. What is the function of an earth wire? It is a safety measure. It protects the person from an electric shock in case the appliance becomes live. Explain why a bat-powered torch has only two connections, because one connection goes to the positive of the supply and the other one goes to the negative. Why does a mains lamp has three? Because it is connected to the main supply. It should have a live, neutral and an earth wire. Now, why is this current electricity dangerous? Generally, we see the symbol that we can see on the screen. It alerts the people if there is a high voltage somewhere. So the main problem with current electricity is it can produce a shock. So when it goes through something that is conducting, which our body is quite conducting, it will cause a shock. And when the after effect of the shock can be that it can cause heart attacks, breathing difficulties, etc. Then other dangers associated with that is, as I said before, overheating can result, and then short circuits, all those things can lead to fire. So these are the dangers associated with current electricity. The high voltage of 230 volts has all these problems. Okay. So keeping all these problems in mind that we just discussed, that is why we are using earthing in these appliances. So as we said before, it is one of the many methods we use to increase the safety of the electrical appliances at home. So the cables that we use in the wiring for the mains electricity has an earth wire. So what does it do? As you can see here, it provides an alternative path for the current if the appliance develops a fault. Now, what do we mean by that? We will come to that. So any appliance which has a metal case should have an earth wire. The reason is metals are very good conductors of electricity. So usually what happens is, if you look at this diagram here, this is how it is. So the wires coming out from the cable goes to the live, neutral, earth like this. Sometimes what happens is this live wire, due to some fault, say the live wire breaks, and instead of going to where it is supposed to go, say it touches the metal. So the live wire, instead of going to the socket where it is supposed to go, it say got separated from there and it touches the metal casing. So since the casing is metal, what will happen? Automatically the casing becomes live. So it is having all that current on it. Now look at this particular connection here. You can see a connection from the metal casing is going to the earth socket. So anytime a fault like that happens and we say the appliance becomes live, all that charge will flow through this wire to the earth through that earth socket. Okay, so that is what is mentioned here. If the live wire becomes loose and touches a metal case, then if that earth wire is not there, though all that charges will stay on the metal case. So unknowingly when we go and touch it, it then flows through to the ground, and that is what we call as an electric shock. So because there is an earth wire like this, the large current then flows to the earth wire, and then there is always a fuse connected to these things. And when that large current is flowing through the fuse, it will then melt the fuse and the circuit breaks. Okay, you don't have to know the details of fuse as per the specification. So the main thing you need to know about earthing is it provides an alternative path for the current. Anytime the live wire becomes loose or there is a fault and it touches the metal casing, all that extra current will flow through the earth wire to the ground. And that will save the person who's going to touch the appliance from getting an electric shock. Now, so we were talking about metal casings so far. But you have also seen kettles and toasters that have plastic casings, isn't it? Such ones, they will not have an earth wire. Why? because the purpose of the earth wire is that if any current flows through the casing, instead of coming to us, it will go through the earth wire to the ground. But if the casing is plastic, then anyway current is not going to go through it, isn't it? So they don't need an earth connection, because they have a plastic case. So since it is plastic, it cannot become live. Normally we use a symbol for all these appliances that have double insulation. This is how it looks like. Okay, and towards the end, let's see how an exam question looks like. So you have an exam question here which shows the internal part of a 3-pin plug, how the inside bit looks like. So label the wire X. What is the function of wire X, and what is the potential difference between the live and neutral wires? So question 1 and 2 we just discussed. If you go back to a few previous slides, then we had mentioned the potential difference of the live and the neutral wire. Okay, so pause the video please, write the answers and then check. Yes, so the first one is the earth wire, so that there is no electric shock is the answer for the second one. Live wire is at 230 volts. Neutral wire is at 0 volt. So the potential difference between them is 230 minus 0, which is again 230 volts. Okay, so these are the main things you need to know in mains electricity. So with this, I have given you a small sheet, which is a Word document. So you can type on the Word document itself and remember to attach it back to Frog. Okay, so if you have any doubts in what I have explained so far, the next lesson when we see, please feel free to ask. Okay then.